Hi guys, we are going to work on lesson 19.2, which is theoretical probability. Theoretical is a word that actually means in theory, all right? What that actually wants to tell us is we're not going to do the experiment anymore, right? Remember we used to do experiments first in lesson 19.1. We're not going to do the experiment anymore. Now, what we are going to do now is to actually calculate the probability in terms of the theory. And for that, we actually need to have some terms clear in our minds. We do remember these two terms, remember outcome and sample space. They both come from the first lesson. The new term that I want you to keep in mind is the event term. It's a set of outcomes to which a probability is assigned. So in a big experiment, remember when we were playing with the dice, the experiment is the entire game with the dice, but an event is going to be a set of outcomes. So out of throwing the dice for 20 times, for about 20 times, an event, that's the experiment, right? The event could be to think about those that are going to get us an addition greater than 10. That is an event. I can also think about another event in the same experiment. I can say, okay, how about I want to get the probability of the dice thrown, which addition is even. Or I can also think about another event in the same experiment. How about we try to calculate the probability for the product of the numbers in the dice we throw to be greater than 15. So that gives us many events within the same experiment. We need to keep this word in mind because we are going to be talking about events all the time from now on. From now on, the experiment is going to be a point of reference, but really is important from now on, it's what is that event that I want to pay attention to and that I want to calculate the probability to. Now, probability in terms of numbers, it's pretty much a division or a fraction, right? That is always going to be in terms of how many outcomes can I get for that specific event A in this case. The probability of an event A gets me the number of outcomes for that event. So the addition is even or the product is greater than 15. How many outcomes am I getting for that event? And then I'm going to divide it into the sample space of the experiment, which is, in this case, the two dice are going to be a sample space of 36, right? As we talked about it in last class. So the probability is pretty simple, but I do need to actually give clarity to those two things in my mind. I need to know what are the outcomes in the event that are possible for it, and I need to know the sample space in terms of numbers. Right here, I don't really care what are going to be the combinations or the options I'm going to be able to get, but I do want to get the number in the sample space. So keeping that in mind, I will be working with you guys in a few exercises, and then of course I will work with a couple problems as well. The first exercises I want to work with you now are part of the section from the first to the sixth exercises, but I will not do all of them. I just want to show you how everything works, okay? I'll do number one though. Number one asks me to get the probability of those getting minted in 2005. Now, when I say minted, that pretty much means created in 2005. Sorry, that's 2002. How do I do that? Well, I need to check for the event. The event is what are the pennies that are minted in 2002? What are the pennies that are created in 2002? I know it's 2. So remember, I need the number of outcomes for that event. So here I know it's 2 possibilities for that event. And then I need the sample space. That means the total in the experiment. So that is 20. So I get 2 20ths. Now I can give this answer as a fraction, or I can give it as a decimal, or I can give it as a percent. All right? A lot of times we give the probability as a fraction, but you're gonna give it to me in all 3. The fraction, the decimal, and the percent, okay? Now let's think about problem number 2, or exercise number 2. That says, what is the probability to get pennies minted in 1995? Now again, I need to see what are the outcomes for that event, which is 1995, and I don't have any, so I know it's 0. Out of the 20 I have in the sample space, and we of course know that is actually 0%. All right? And then we're gonna work with problem number 3. Problem number 3 tells me about what is the probability of pennies not minted in 2004. Here I need to talk to you about complementary events. What are complementary events? Pretty much when we have one event, the other option to complete 100 is everything that is not it. So think about a bag with marbles, right? If I have marbles of different colors, and then say I have 5 marbles, or the 3 marbles we had yesterday. I'm trying to get one out, right? And it's different colors for each. Then if I want to have the probability between blue, red, and yellow, and I get out the probability of red, for instance, then I know the probability of not getting red gotta be the other 2 that I still have in the bag, right? So having the probability of having one event, it's always the total minus whatever is not that event. Or the probability of not having that event gotta be the total minus the probability of the event. So in this case, think about the probability of not being minted in 2004. So this is 2004. So this one is not working. I mean, I don't need this one over here. The ones I need are everything that is not 2004. So I need 2002, I need 2003, I need 2005, and I need 2006. If we add this, that is actually 6 and 8, 14, and 1, 15. So here, it's 15. Now, could if I just said 20 minus 15, minus 5 equals 15? Sure. That is what complementary events tell us. Take the total, subtract what you have, so you can get everything that is not it, right? You could have also get it that way. And then the total is going to be 20. So as you can tell, that is actually 3/4. And that's going to be 75%. All right? This is the first section that is going to allow you to actually do many exercises in the lesson. Now we're going to work on exercises 7 to 9, which, yes, we're going to calculate the probability of the events, but here numbers alone are not going to be enough. So we actually need to use the sample spaces we were creating in lesson 1 to be able to answer these problems, all right? So if I have to flip 3 identical coins, we of course need a tree diagram. So I'm going to do that. I know I have to do the first coin here, which is heads, and then tails. Then I need to do the second coin here, which is going to be again heads or tails, heads or tails. And then I'm going to have a third coin over here. And then I'm going to get, again, 2 options for each. So I'm getting heads and tails all along, right? That actually gets me a total of 8. I have 8 in the sample space. So I know the sample space here, it's equal to 8. Now, number 7, problem number 7 tells us, okay, you need to get the probability of 3 heads. So we have to get the probability of 3 heads. Now remember, we need to have what are the outcomes for that event. So here I need to establish how can I get 3 heads. And if you look at all the branches, this is the only one that actually works. Only 3 heads. So I only have one option out of the 8. So for my event, I have 1 and the total or the sample space is 8. That would be my probability. Now I can convert that probability into decimal and then into a percent as well. But you already know how to do that, of course. Let's do number 8. Number 8 says get the probability of 1 head and 2 tails. Okay? So now I'm going to erase over here and then I'm going to look for that again. I need only 1 head. So this part doesn't work for me. I'm gonna look to these 2 branches. Now in these 2 branches, I'm only gonna be able to use this one over here because I have 2 tails and 1 head. Now here, I'm gonna have 2 tails here and only 1 head, so this one also works. And 2 tails and only 1 head, so this also works. So I have 3 for the event, that are my outcomes for the event, and the sample space is 8. Once again, you can convert it to decimal and then to percent. And then 9, it's the probability of no heads. Again, this is complementary events. So I need to know what is no heads. Now remember I have 8 and I need everything but heads. So this is all, here I have heads, so that is 4. And here I have heads and heads. So there's only one option that has no heads, right? So it's 8 minus 7 is 1, or I can just check on that in my mind. So I'm gonna erase over here again. And this is gonna be my only option for this. So here I'm gonna have 1 option out of the 8. So once again, I get 1/8. And since you already got the decimal and the percent, you just have to write it down again. You don't have to do any more processes there. The problem I want to work with you says, if it's number 23, and it says, if you draw a marble without looking from a jar filled with black and white marbles, you are 3 times more likely to draw a black marble than a white one. If there are 60 marbles in the jar, how many are black? Think about this. We have the jar, it's filled with black and white marbles. The total of marbles in the jar is 60. And they have tell us that you have, for every white marble you have in the back, you have 3 black marbles in the back. How do we know that? Because it says 3 more times. So we can actually write it down as our ratio, okay? Now, they tell us, okay, how many black marbles do we have? If we know the addition between the amount of white marbles with the amount of black marbles gets me 60. So here we gotta come back a little bit in proportions, actually farther back and going to ratios, and we're gonna work with equivalent ratios. But we gotta be careful at one thing though. And the one thing we gotta be careful at is the equivalent fraction, the equivalent fraction or the equivalent ratio we wanna get is actually related in terms of whatever I'm getting up and down, I need to add it to get 60. So I'm not supposed to get 60 either up or down here. But the addition of the 2 values here get me the 60 down here, okay? So let's think about that. I'm gonna start with 10. If I multiply by 10 in both, I'm gonna get 10 here and I'm gonna get 30 here, right? So if I add that, I get 40. So this is not what I want. That's not good for me, right? So what I'm going to do is to try something else. I'm gonna start with 20 now. 20 and then 20. And if I do that, then let's see. Well, I'm gonna have 20 up here and I'm gonna have 60 up here. That's a problem because I'm not supposed to get 60, right? And if I add them, of course, I'm gonna be way out of my goal. So I don't wanna do that. So I know it's between 10 and 15, right? So let's do it. I'm gonna go with the between, so that is 15. I'm gonna go with the between. Here it's 15 and here is 45. Well, that actually makes sense, because if I add those two, then I'm getting 60. So this is the ratio I was looking for, and then this is my answer. There are 45 black marbles in the jar. Okay? But that is kind of using everything you know. And then there are a lot of problems you actually need to do that. So be just careful with your analysis skills. Okay? Every other problem is just a matter of actually calculating probabilities, whether it's with the formula or with the sample space itself. Okay? I'll see you for the next lesson. Bye.